Now, technical interoperability layer. So basically, what is technical interoperability? It is the ability of systems to exchange data at the transport and protocol level, regardless of content meaning. Right? Ability of systems to exchange data at the transport and protocol level, regardless of content meaning. Key traits: domain independent. It cares about bits and bytes, not the semantics or the meaning. It is based on information theory given by Shannon. Transmission of information through a channel with minimal loss, and layers corresponds roughly to OSI layer 7. Example: system is EHR, electronic health record, sends HL7 message to network, and then it sends to system B is EHR. So it would system A sends the message and system B is the receiver. Both pass their own formats. Analogy: you send a text in English to a channel, and the friend receives it and interprets the meaning. So technical layer is for the signal transmission, and semantics is for the high layers of OSI. Pitfalls: confusing technical versus semantic interoperability. For example, systems can exchange JSON but still misunderstand fields, right? Now, what is HL7? It is health level 7 international. So health level 7 international is basically a global standards development organization creating data exchange protocols for healthcare. Health level 7 international mission is to enable interoperability between disparate health systems, EHR, labs, pharmacy, and imaging. Level 7 refers to the OSI layer 7 application layer. Core standards family HL7v2.x, that is version 2. Legacy pipe delimited messages. Then we have HL7v version 3, model driven XML based. Then we have CDA, document standard for discharge summaries, and FHIR, which is the modern REST API framework. Now, information interchange requires translations. So internally, we have the wire format like systems native structure for standard messaging. Then we have wire to internal format, message to receiving systems data structures. For example, hospital database sends a HL7v2 message, and the lab system passes it to database. Now, object-oriented software development steps. So stage and the meaning. So first we have the CIM, that is computational independent model, which describes domain concepts storyboard level. Then we have PIM, that is platform independent model, that is an abstract design independent of the tech, that is only the unified modeling language UML diagram. Then we have PSM, that is platform specific model, that is implementation details. For example, what stuff are we going to use, that is what is the technology stack, tech stack we will be using, like FHIR REST APIs being used, and HL7v2. Then finally the code, that is the actual executable code, which is in wire format. Now, pitfall is mixing semantic design and code generation too early, which leads to poor interoperability. Now, syntactic interoperability is basically the agreement on structure or format of data, so it can be passed regardless of the meaning. So HL7v2 message looks something like this. We have first the message header, then a pipe delimiter, then this comes, then lab, hospital, EHR, hospital, then the unique identifier, and then this. Here, both sender and receiver understand that this is the field delimiter, PID is the patient segment, that is the unique ID. That's syntactic consistency. Difference from semantic interoperability is basically semantic systems also understand sing, which is the family name, and this number, which is the birth date here, right? So that is 14th of February 1985. Now, core idea for REST representational state transfer. Definition is REST is basically architectural style using HTTP verbs, get, post, put, delete to manipulate resources identified by URLs or URIs. Principles: it is stateless, each request is independent, it is resource oriented and has a uniform interface, it is cacheable and basically has client server network, and we use hyperlinks in this, right? So get the request patient 123 returns JSON representation of patient with ID 123. In FHIR, every clinical concept is equal to resource with references to other resources, that is that they are interlinked, extensions, that is custom fields, and XHTML text.div human readable narrative. So augmentation: FHIR also supports messages and documents in bundle types, right? Pitfalls is misusing posts, that is create for updates, should be put, right? Now, FHIR standard overview. So FHIR stands for Fast Healthcare Interoperability Resources, which is HL7's Health Level 7 International's latest standard combining the best of version 2, version 3, and CDA with web technologies. Key traits: open source, community driven, JSON XML serialization, modular resources for all healthcare entities, built in narrative text, and formal maturity model levels 0 to 5 linked to implementation feedback. Now, architecture layers: resource model, RESTful API, terminology bindings, and conformance layer, that is profiles and IGs. Now, what are the maturity levels in FHIR and why are they important? So, levels 0 to 5 indicate how widely a resource has been tested and adopted, helps implementers assess the stability. Now, HAPI, Happy FHIR, and Google OHS, that is Open Health Stack. So, HAPI, Happy FHIR is Java-based FHIR server client library, which is open source, right? And supports validation, terminology, bulk data, and smart on FHIR. We have some example URLs. Then we have Google Open Health Stack OHS, which is open source cloud FHIR toolkit, right? Focused on public health and low resource settings, and implements full end-to-end FHIR data flow from collection to syncing to analytics, right? Now, FHIR model scope from general to specific. So reference model is the level first. Example HL7v3 RIM, that is reference interoperable model no, RIM, then ISO RM, then FHIR core resources. Scope very general and conceptual. Then domain specific specification, CDA templates, FHIR profiles, technology independent but constrained. Then implementable syntax, JSON XML schemas and REST endpoints, concrete implementation, and specific. Why do we use layers? It keeps standards flexible and technology neutral and encourages reuse across multiple formats. Now HL7 v3 RIM, which is reference information model, and RMIM, right? So firstly, HL7 v3 RIM, which is reference information model. It is an abstract meta model defining universal building blocks for clinical information, which has entity, that is the person, the device, the organization, and the role, that is patient, provider, or performer, act, events like observation and encounter, participation, who did what to whom, right? So we have an abstract meta model defining the universal building blocks for clinical information, including entity, role, act, and participation. Purpose is it provides consistency across messages and domains, and also it is not directly implemented. It is used as a conceptual foundation. For example, in a patient visit, we have entity, which is the person, John Doe, right, belonging to whichever organization, right? And we have the role. What is the role the person is performing? He is the patient. John Doe is the patient. Act, events like observation or encounter. Act is an encounter. Participation, who did what to whom. So patient participates in the encounter. Now we have the RMIM, which is refined message. First we have the reference information model. Now it is refined message information model, which is a specialized implementation model derived from the reference information model for specific use cases like lab result and encounter summary. Now, example, RMIM encounter message looks something like this. Act as encounter, consultation, participation, patient John Doe, participation, Dr. Smith, observation, blood pressure 120 out of 120 upon 80. A specialized implementation model for specific use cases, which is derived from RIM, is refined message information model, RMIM. Now, RMIM is basically RIM plus the constraints and the domain context. It bridges the gap between abstract model and implementable message. So explain how the reference information model concepts, entity, role, act, participation relate to real world FHIR resources. So in FHIR, patient, which is the entity or the role, practitioner, entity or role, and we have the encounter, that is the act, and the reference links, that is the participation. Now this is the Python code stuff for RIM. We define the entity, the role, the act, and the participation. So entity, role, act, and participation. And we have extension from RMIM where we have the encounter message as well and adding more participants, right? Now FHIR patient resource, this is another example. Resource type is patient, ID 123, that is the unique ID. Then we have the name, right, and gender, birth date, and address where he lives. So mapping to RIM concepts, FHIR element, patient, which is the resource, and for RIM it is the entity or the role. Identifier is the entity dot identifier. Then we have name, entity dot name, gender, role characteristic, and address, entity dot address. Now this is the summary. You can go through it, right?